Assalamualaikum and very good day to my panel. My name is Muhammad Aidil bin SUHAIMI and my ID number is 2019017201 and my supervisor name is Dr. Farah Shaida binti Muhammad Saleh. Today I'm going to present my final year project to co-injection molding process of polylactic acid PLA/polyethylene terephthalate PET using MOLDEX3D. Here is my content in this presentation. First, abstract. Second, introduction. Third is methodology. Fourth is result and discussion. And last is conclusion and recommendation. Okay, first part of this slide is abstract. PLA is become attention as one of the most advanced polymer being explored for a variety of applications such as regenerative medicine and tissue engineering, while PET is a transparent, sturdy, lightweight plastic frequently used to package food and beverage. PLA and PET material were utilized in this study to evaluate the flow behavior of simulated products using MOLDEX3D software, which may be used as reference for co-injection molding process parameters. The rheological data and important properties of PLA and PET co-injection molding may be obtained from the software material database to build a machine for fluid flow analysis. Second part is introduction. In introduction, I want to talk about the application of PET. PET is commonly utilized in the large-scale manufacture of bottles for storing soda drinks and other beverages because it is light, sanitary, and retain the bubbly flavor of carbonated beverage for a long period. Second point is PLA properties, where PLA is a renewable, processable, biocompatible alternative material for biomedical application and energy saving. On the other hand, PLA is a brittle and has limited temperature resistance. Third point is description of co-injection molding, where co-injection molding are known as sandwich molding, create a sandwich structure which consists of two polymers bonded together. Fourth point is the advantages of using co-injection molding process. This approach was created to provide for greater flexibility in part design and manufacturing by exploiting the best feature of each material. Next point is computer-aided design (CAD) and computer-aided engineering (CAE), where CAD system assist in the efficient creation of a new product, while CAE systems are used to forecast and analyze future capabilities of a product. The last point is a numerical simulation of powder injection molding (PIM) and powder co-injection molding (PCM), where powder injection molding (PIM) process can providing a theoretical foundation for mold design and injection parameter optimization, while for the powder co-injection molding (PCM) process, a numerical model was suggested to forecast the co-injection phase. The problem statement for this study are: first, there are lack of co-injection simulation study in polylactic acid (PLA) and polyethylene terephthalate (PET) plastic using MOLDEX3D. Second, there are lack of information of filling time, warpage, and packing time for polylactic acid (PLA) and polyethylene terephthalate PET feedstock in simulation. Third is lack of study in combination of polymer polylactic acid PLA and polyethylene terephthalate PET. The objective for this study are: first objective of this study is to generate a 3D model by using CATIA software, and second, to simulate MOLDEX 3D software to create and co-injection molding device, and third, to analyze the shrinkage and warpage after run the simulation in the MOLDEX 3D. For the scope of work, first, CATIA and MOLDEX 3D software is used to produce dot bone part, and second, PLA and PET as a simulation material, and third, co-injection molding parameter, which are injection pressure, injection temperature, mold temperature, back pressure, are used in this simulation. And fourth, output of the study are shrinkage and warping. For the methodology, here is the dimension used for crate dot bone specimen where 75 mm in length, 1.6 mm in thickness and 14 mm in breadth was created using the CATIA software. For the mold system design, the best gating position is needed because it may prevent fall in the study of the mold design system was conducted. The gate is positioned in the center of the dot bone. The need of configuring the mold design in order to ensure that the simulation of material performed in a good condition. For the meshing dot bone specimen, the triangular size used is 0.5 mm and the tolerance is 0.5 mm and it producing mesh node count 41,832. For the mesh element count is 114,970 and mesh volume count is 1.18 centimeter cube. Here is material information used for this study. PLA Naturework Ingeo 3251D is used as a scheme material while PET BASF Petra 7030 is used as a core material. This maximum and minimum temperature of the material and mold are important for doing the simulation. For the co-injection molding simulation, full analysis, which are filling, packing, cooling, and warpage, is used in analysis sequence. The result of the simulation can be seen at the left side of the screen. In the warpage and shrinkage result, the sixth trial has the lowest warpage of 0.897 mm, although the shrinkage is not the lowest at 10.653%. Then the seventh trial has the least shrinkage, 10.136%, and warpage 0.967 mm, both results which are still minimal when compared to the second trial. Coolant temperature and packing pressure, mold temperature, injection duration, and melt temperature were collected from prior research and the range were derived from the MOLDEX3D suggested processing. Here is filling melt front time for core and skin, where max filling time is 0.179 seconds in blue color and minimum filling time is 0.08 seconds in red color. Material used are PET for core and PLA for skin. Here is a side view for dot bone specimen where we can see the PLA which is skin material in the white color and the PET for core material in the colorful color. Here is a core injection flow process of core and skin material into cavity from the top view and the side view. In this result and discussion session, the sixth trial is selected because that shown the lowest value of warpage. For the filling pressure happen in the simulation, max filling pressure happen in the sprue which is 175.005 megapascal and indicate in red color. Green color filling pressure value is 97.946 megapascal happen in the middle of the dot bone and the lowest filling pressure happen in the left side of the dot bone which is 20.007 megapascal. For the sink mass displacement, the maximum value indicate the red color, which is the value is 0.06924 mm, and the minimum indicate blue color, which is 0.00462 mm. For the well line, the maximum filling well line is 0.179 second, and the red color shown the value 0.001 second. The welding angle of this simulation is 180 degree. For the volumetric shrinkage is defined as the percentage increase in local density from the end of the packing phase to the ambient reference temperature, default 25 degrees Celsius. The maximum volumetric shrinkage is 10.653%. However, in this result, it shows the specimen section is green, light blue, and dark blue, indicating reading of 3.645%, 1.018%, and negative 1.61% respectively. Negative volumetric value indicate that the thing is growing rather than shrinking. For the total displacement warpage, it shows maximum total displacement warpage value is 0.897 mm happen in the end of the dot bone, while minimum total displacement warpage value is 0.06 mm happen in the middle of the dot bone. The result reveal that the displacement result on the component determine the distance a node has moved from its initial location. For the conclusion, by using coolant temperature of 30 degrees Celsius, met temperature of PLA 195 degrees Celsius for skin material and PET 310 degrees Celsius for core material, mold temperature of 30 degrees Celsius, injection time of 0.1 second, and packing pressure of 250 megapascal, it produced the filling time 0.179 seconds with the largest volumetric shrinkage of 3.645% occurring in the dot bone, 0.06924 mm sigma, and 180-degree filling well line. The lowest warpage is 0.897 mm in the sixth trial, and the lowest shrinkage is 10.136% in the seventh trial. So, the objective of this project is achieved. The recommendation for reduce the defects such as well line and sigma mark happen in the study are decrease the specimen thickness, second, alter gate location, and third, add vent. That's all for my FYP presentation. Thank you very much for your time. For any inquiry, you can contact me through my email and phone number that had attached here. Assalamualaikum warahmatullahi wabarakatuh.